So I do need you to turn your notebooks back in. This is why I despise having Maroon Day tests, is because on Maroon Days I think, yeah, I'm going to get to that. I don't get to that. I'll do it during Spartan time. Nah, kids come in for help during Spartan time. I'll do it after school. Oh, wait, no, I'm also helping a kid after school. And it just kind of devolves from there. So give me your notebooks back after this. During third block, I am just going through notebooks and binders. I'm doing nothing else. You come pick them up after third block or at the end of the day before you go home. Okay? If you need your notebook for third period, tell me. I'll get that done during lunch. Okay? But I do need those back because I literally got 2.5 done. And that's it. So, Gretchen, stop it. Keep putting it in the wrong pile. Half the time I find yours in the wrong class. Killing me, Smalls. All right. Before we get rolling, I had told the whole lot of you on Friday, leave room. I had said leave like half of the space. We're going to do it a different way. Yes. I had wanted you all to solve this however you solved three variable systems before. There we go. Oh. Well, I mean, y'all got to step up your game. You're right after the other class. If I'm going to make an error, I'm probably going to make it in that class and then remember it in this class. Bring it. Okay. The idea behind it was that in most cases, we eliminate a variable two ways, right? We'd get rid of x, we'd get rid of x. Now I have two different equations that have y and z only. Well, if I've got two equations with two variables, then I'll just go solve a two-variable system like I'm back in algebra half. And then, after that, well, if I solve for y and z, what do? I know y, I know z. Go all the way back to the beginning, and you solve for x. Or in this case, I'll say solve for the variable that was eliminated. That was the general idea behind three-variable systems in Algebra 2. And it's simple enough that this year I think they even tried bringing our three-variable systems down to Algebra 1. It's not that bad. What we're doing today and tomorrow is we're showing you a different way that is more efficient. What I mean by more efficient is, let's be honest, some of you, when you do your three-variable system, it looks like Madden's football play from hell. You got letters and numbers all over the place, arrows drawn over here. Even when I do it, I have my three-variable system to start with. I'll come over here. Here's my two equations. Here's my two equations. And then I get my two equations that are down to just y's and z's or whatever they are. And then, well, now I have a two-variable system. I'll go solve that two-variable system, bring it all the way back, and then I solve for whatever that initial eliminated variable was. So if you remember from way back at the beginning of the year, even I take up an awful lot of room for these, because you have your eliminate a variable two different ways. It gets you a pair of systems, or a pair of equations that are down to two variables. So I solve my two variable system, and then I finish it off by coming back here and solving for whatever it was. But it takes up an awful lot of space, and even with that organizational map, I always do it in that like loop. Even with that organizational map, even with writing stuff next to it, and writing 3 and then equation 2, even by putting all that stuff next to it, it can still be an awful lot going on. So what we're going to do is we're heading towards matrices, where I can get rid of all the alphabet soup, I can get rid of all the extra steps, and where we're headed, if you got the mental math mojo for it, is you will start with your initial problem. I'll eliminate two things. I'll eliminate two things. I'll eliminate two things. Answer. Ding, 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 ding. Done. It's very neat and organized. And next to them, I'm going to have my instructions. Next to them, I'm going to have my instructions of how I got each row in the matrix. But in order to do that, we got to go baby steps. We have to learn what even row echelon form is. We have to know what Gaussian elimination is. That's why it's a 2-day thing. So, row echelon form. Have you ever even heard the word echelon before? Okay. Echelon means rank, order, hierarchy. If something is in row echelon form, that means put your rows in order of their rank or hierarchy. The goal in this type of elimination, this type of solving a system, is I used to have x and y terms here, and I want to knock out this triangle of values. Because if I knock out that triangle of values, I get all the way down here and I got z. Well, what do I do now? If I know what z is, I'm going to put it here and here. Well, if I know what z is, this is now -8, add 8 to the other side. Now I know y is 3. What do? Go plug it in there. So if I eliminate this triangle, then I'm able to domino effect my way back up the pyramid, and this leads into Gauss-Jordan elimination tomorrow, to then knock out this triangle, but I made it into a trapezoid. Okay? In order to do row echelon form, we got to follow the rules. Those are my rules. Y'all been on teeter-totter, right? Seesaw, whatever you call it. On those, it's right here, okay? Fulcrum. If this side is balanced with this side, the one right next to them, okay? Balanced. I should be able to take the ladies and have them jump on this seesaw. And if those two are balanced, then now this is still balanced, right? Balanced, balanced, all together, still balanced. Well, that's how we were solving systems before by elimination, is I can add together any two rows at any time because they're balanced. I can also multiply a row by whatever I feel like. I could take this whole row right here and just fruit ninja through their torsos, cut them all in half, cut their weight in half, and it's still balanced. It's capital murder, but it's balanced. And I can also, well, maybe I don't want to cut them in half. Maybe I want to double all of them instead. Okay? Could all of their weights double and we're still good? Yeah. And I can also exchange rows at any time. Maybe I just say, I'm sick of looking at you four goobers every day in the front row. I'm going to have you go to that row and you two come up to this row. Okay, I can do that at any time. Well, there it is. There's your three rules. If you follow those rules, then instead of putting your equations all over your paper, I can keep them nice and neat and packed together and organized. That's what this is about. Okay? So, step one, I'm going to rewrite this because I don't like having that equation 1, 2, 3 off to the side. Anyone else smell it? They're mowing outside? Can you smell it? No?
Well, now that you say it, I can smell it again.
Okay. So,
Are you in a place full of teenagers, Jeff? Like
what?
just really strong.
Your class in the middle of the school. Something about a window.
I said that on day one. Said if any of you got a little too much sauce on, I'm kicking you out of my room. Game club, I've had to kick some kids out. They haven't figured out that deodorant thing yet. Well, there's like 2 or 3 of them. I got my air filter still. I leave that on every night after. Boy, I wish I had a window. But before I go doing anything with this, before I go trying to eliminate this triangle of values, the first thing that I really want to do, can I make my life easier? Look at all rows of that system. Can I make this a little simpler? Okay. So stage one is I'm going to say 1/5 equation 1. Okay? And I'll write that. So 1x, oh wait, I was just doing matrices and I'm all discombobulated now. I got to go back to the beginning. X minus y minus z is 7. Now I'm not going to do anything with these yet. So I've got equation 2 plus 2y minus 3z is negative 12. 3x minus 2y plus 7z is 30. Actually, now that I think about it, y'all might get some brownie points off me just by trying to revert back to matrices. Now that I'm here, my goal, again, is to get rid of this triangle of values. That's my purpose. That is Gaussian elimination. Gauss was this, famous dead dude, did math. And Gaussian elimination becomes real easy if up in that top left corner, I've got a 1 or a -1 as a coefficient. Because I can take 1 or -1 times whatever I feel like to eliminate things, right? I could have a 7 and a -32.6 below it. I can take 1 times 32.6 and it goes away nice and easy. So that top left corner, because it's so important, because I want to have a 1 or a -1 there if all possible, I just kind of refer to it as my command zone. That's going to be the spot that I use to start the process. So, right below that, tell me, I'm not going to do anything to equation 1 yet. I'm going to leave that as x minus y minus z is 7. How would I get rid of that -x in equation 2? What? What are my rows? What are my rules? I can multiply a row by anything. Did that to start. I can add any two rows at any time. I can add multiples of rows at any time. I can swap rows. Okay, so write that. Say equation 1 plus equation 2. And you do want to write it off to the side of this, on the left side, because this is going to be my directions. Anyone should be able to pick up your paper and follow your directions through your work as we're doing this. X plus a negative x, gone. Negative y plus 2y, y. Negative z minus 3z, negative 4z. 7 minus 12, negative 5. Now when I said that we're going to do this in a nice compact area, we're just being more efficient with our work. Instead of doing two separate equations, systems, I'm just going to keep going here. What's a way that I could knock out that 3x? Close. I could either do negative 3 equation 1 or positive 3 equation 2. Which one makes more sense? Both are equally correct. I'm going to choose option B because if I don't have to multiply by a negative, that's one less thing for me to screw up. So I'm going to say equation 3 plus 3 equation 2's. Or you can say 3 equation 2's plus equation 3. You know, addition's commutative, doesn't matter. So, do you got the mental mojo? Times 3 and add it. Gone. Times 3, 6y, and add it. 4y. Times 3, negative 9z plus 7z, minus 2z. Times 3, negative 36, and add it. Do you see how, if I'm trying to get rid of this triangle of values, the first step would be to use that 1 up in the command zone to knock out the x's right below it. Because now I only got one critter left that needs to go. You go away. You go away. Oh, first hour was freaking out because they'd never seen this before.
We did that last semester.
Yeah.
Right?
The first time you did it last semester.
I'm like, these smart boards are as old as you. How have you never seen that before?
No teacher ever does it.
But it's fun.
Or when you
No
do,
other teacher likes fun. Yes.
Like,
when you do magic,
let's play Pong. Aww.
Do it in one line. Yeah, draw the square.
Okay. So, now the goal to finish off that triangle for row echelon form is to knock out that 4y at the bottom. I'm not going to touch equation 1. X minus y minus z is 7. I'm just writing equation 2 here. Because I'm always referring to the set immediately before it. Yes, I know this equation 2 was really the original 1 plus 2. But wasn't that 1/5 of 1 plus 2? You don't want to keep writing the instructions every time. Like, you know, the whole xenophobic, like, culturally whitewashing version of Ellis Island where they said, I have no idea how to pronounce your name, so you are now just going to be Johnson. You are now just going to be Smith because you make things. Like, that idea, well, it wouldn't make sense to take your name, your lineage, and include every one of your ancestors and say that in casual conversation. John Jacob Jingleheimer Smith. Like, you don't put the full set of directions. You all went through geometry, kind of. You all did proofs After you proved a theorem, you didn't do the entire proof of the theorem to use it. You just said the theorem, right? I'm not going to include all of those directions here. I'm just going to refer back to equation 2 from here. Okay? When I say equation 2, I mean the second equation in the thing before it. Don't overcomplicate things. It just depends on the one that came right before it. Now, what would my directions be to knock out that 4y? So I'll say equation 3 minus 4 equation 2's. Okay? Now, you hear the, but you could do it with just 4 of equation 1. Wouldn't the x cause problems? Okay. I could use 4 times equation 1, but if I did, I would be dropping a 4x into the spot that I just vacated. That would be, I just vacuumed this rug. Why are you dumping out your bag of Cheerios? That's Goblin 2. Okay. So I'll take this times a negative 4 and add it. Bye-bye. Take that times a negative 4, 16, z, and add it. Take that times a negative 4, positive 20, and add it.
That's supposed to say 16Z.
What? No. Times negative 4 is 16z, add it. So you're going to start getting this idea of if you can handle the moving parts, if you can handle the mental math, I just took blah and turned it into 1, 2, 3. I am now in row echelon form. If I'm in row echelon form, I can come down here and answer this real quick. Z is 1. Well, if I know that z is 1, go dump it into equation 2.
Negative 1.
I get y minus 4 is negative 5. Add it over, I get y is negative 1. If I know those two, can I plug them in here and get x is 7? Now, if you need to write that out, do it. If you need to say x minus negative 1 plus 1 is 7. If you have to write it out to see it, then write it out to see it. And my answer is a three-dimensional coordinate x, y, z, 7, negative 1, 1. Any of you ever played around with three-dimensional graphing? You have a y-axis from top to bottom. You have a x-axis from side to side. And you have a z-axis from back to front. So if I'm at 7, negative 1, 1, 7 on the x-axis, right. Negative 1 on the y-axis, down. Positive 1 on the z-axis, forward. So it would be in that front bottom eighth of the cube. Now you don't have to graph it. You just have to write that. But can you eliminate that triangle? Can you do it in those steps? Because this is leading us towards solving by matrices. Okay? But we usually start by doing Gaussian elimination with regular variable systems to kind of dip our toes into the water first. Any day now. Cancel 3, -4, -3, 5, by 3, by 3, 2. 2, -1, -12. -2, 1, 12. -2, 1, 12. 1, 12 times 4. -8, -8. 3 is 11. 12 by 4 is 48. 48, -30.
Does it matter?
3 is 70. Damn it, child! What?
Does it matter what order you eliminate them?
No.
So I can start with like the normal house.
You want, as long as you take out that triangle.
Okay.
Right there. 3, -1, 1, 3, -12. 3, 1, 2, 2, -1, -12. Times -4, -4, 3 is -1. Is -45 by 5, 9. Right? Is that 1 or -1? See, you ruined the whole thing. 1, 2, -3, -28. 2. Okay. Now I'm betting a lot of us get here and then, but wait, it doesn't just nicely multiply by 4 and go away. Do you at least get here? Okay. After this point, you got options. And those of you who really liked parts of Algebra 1 and 2, but hated geometry, because in geometry, like with the proofs, there was different ways to do it and they were all right. You're gonna have fun with this because there are 24 different ways to start this problem. And each of them then has another couple hundred permutations. A single problem has several hundred ways to solve, and they're all correct. So, option 1, I can't do mental math. So option 1 says, I cannot take 2 times an integer value to get rid of 3. Could I do 3/2 of equation 2 minus equation 3? You can. Times 3/2 is 3. Minus 3 is gone. Times 3/2 is negative 3/2 z. Plus 4z is 5/2 z. I could do that. I know how much y'all love fractions. So we'll skip that one, even though it's perfectly legal and it is the fastest way there. Option 2, I can mental math. X plus 2y minus 3z is still negative 28. 2y minus z is still negative 12. But what is the least common multiple between 2 and 3? How would I turn this into a 6? How would I turn that into a 6? Can I do 3 times equation 2 minus 2 times equation 3? Can you do it in your head? Can I take this times 3, this times negative 2, add them? Gone. Take this times 3, this times negative 2, add them. Take this times 3, negative 60, or negative 36. Take this times negative 2, positive 66. Positive 66 and negative 36 is 30. Can you do that? Okay. Option 3. Nah, I ain't got the steam for that right now. So let's do a shortstop instead. Shortstop says instead of going from here to here to here, done. Well, almost done. You got to z is 6 and work your way back up. I could go over this way and say, how about I leave equation 1, x plus 2y minus 3z is negative 28. I'll leave equation 2, 2y minus z is negative 12. And how about right now I just take equation 3 times, oh, negative 2. What if I just do them piecemeal? Take that times a negative 2, negative 6y. Take that times a negative 2, 8z. Take that times a negative 2, 66. I'm doing the same thing. I'm just doing it piecemeal. Instead of one-shotting it like this, I'll do it in 2 steps. Because now, how do I knock this out? Equation 2 times 3. So I'll say I haven't touched 1. X plus 2y minus 3z is negative 28. I haven't touched equation 2. 2y minus z is negative 12. But now I'm going to say 3 times equation 2 plus equation 3. 3 of these and add it. Bye-bye. 3 of these and add it. 5z. 3 of these and add it. 30. So you have the choice of option A. Option B. They both got you there, didn't they? Option C, the fractions that I didn't even write up there. So it is your choice. Okay? And that's why every year there are some kids who say, the trig stuff was the worst thing I've ever experienced in my life. I never want to do that again. There are some kids who say, that was easy. What the crap is this? And they hate matrices. It's kind of 50-50 split. Now, once I'm here, z is 6. If you have to write it out, write it out. 2y minus 6 is negative 12. Add 6, divide by 2. Y equals negative 3. If you have to write it out, write it out. X plus 2 of these minus 3 of those is negative 28. Negative 6, negative 18 is negative 24. Add 24 to the other side. X is negative 4. Okay. Write your 3D coordinate. Negative 4, negative 3, 6. You ever get your vehicle stuck? Do you just keep hitting the gas and hope eventually you make it through the drift? Or do you back it up a little bit and then take a run at it? Back it up a little bit, take a run at it. And you rock it back and forth. Well, sometimes you might have to take a step backwards to get through the problem. And what I mean by that is, you notice here I don't have a y. But if I want to, oh, here's more board magic. If I want to get rid of that triangle of values, what's going to happen as I try to knock out x's? I'm going to end up putting a y there, even though there's not one there right now. That's okay. Get rid of the x's, then go get rid of the y's. Before I start that problem, though, could I rewrite it in such a way that it is easier for me? Okay, so the bottom row, I can take a 2 out of there, so I'll say 1/2 row 3, or equation 3, negative 3x plus 2z is 0. I can swap rows at any time. And it's if I got that 1 or negative 1, that top left corner, that command zone, it makes everything below it a lot easier. So I'm going to swap. I'm going to say equation 2, equation 1. I'm going to say negative x plus 2y minus 4z is 18. 3x plus 5y plus 8z is negative 20. So just my very first step is to clean it up and arrange it in such a way that it's going to be easier for me. Now, go get rid of this triangle. Start with your x's, then move on to y's. Go. You can use 2 to get rid of 3. You can use 1 to get rid of 3. You can use 1 to get rid of 2. Remember, on your next set, this is now just equation 1, 2, 3.
So we'll put down 1.
As 2, or like,
These instructions to the left of it are how I got here. Now that I'm here, this is just equation 1, 2, and 3.
And then after you do your next.
And then after I do that, this is just equation 1, 2, and 3. Because otherwise, you would have this like quadruple parenthesis set of instructions next to every one of them. And it'd be a mess. No. Times negative 2 times negative 5. 5 times 2. Negative 5 times 2. 5. 8 times negative 5 times 2. Negative 20. 36. One 36 times 165. 69 and 3. 69 and 3 is 12.
Does z equals 0?
I think it does.
I think it does too.
So I have an equation that's 5y plus 6z equals negative 20 and 5y plus 10z equals negative 20. So I think z is 0 and then y is negative 20. Like these two equations, because that would make z not have to equal 0, but most likely. Especially if you
Keep running it. But I'm pretty sure it does, yeah. Nope.
No.
Nope. I goofed something.
I goofed up too.
Then maybe I do something too. But I guess we're fine.
Did you have any multiple? Should be. Why didn't you? Oh wait.
Wait, no.
I should know.
Yeah, 4z equals 0. I got it for one of my final equations. I don't know. I might have done it wrong, but
You're right. So you should have. Just multiply the first one.
yeah. Nice. No. 2 minus 3. Reset it. Oh, I meant 2 minus 3. 1 minus. That's equation 4. Right. Yeah, I know, bro. Since this is a new matrix, I just renamed it.
Remember, the way that I'm doing it is one way to do it. Doesn't have to be the way that you do it. Purple is what we had generally agreed on, so everyone should have started there. I eliminated my x's 2 different ways. Equation 2 plus 3 equation 1s. So negative 3x plus 3x gone. I said equation 2 plus equation 3. 3x plus negative 3x gone. Remember, after I do the stuff to get to purple, this is now equation 1, equation 2, equation 3. Once I'm there, I'm just at equation 1, 2, and 3. Otherwise, you're just going to keep piling on sets of directions. You know what happens when you pile on sets of directions? You get really dumb songs like the 12 Days of Christmas. Because let's be honest, if you have to sing the second day of Christmas, if that's just your assigned part, you hate that. Because you have to do it for the next, you got to do it 11 times. Don't you just want to be the 12th day of Christmas? Because then you just have to say it the one time and you're done? Yeah.
So for whatever reason, I did, for like in the blue part, I did the first equation saying you have it, and then I have equation 2 plus equation 3, and equation 3 plus equation 2. So
That's why you ended up with z equals 0, because you didn't eliminate a single variable 2 different ways.
So that does mess it up though.
Because if you eliminated the same variable the same way twice, you don't have 2 different equations now to put together. You have the same equation twice, and when you put them into each other, you get the identity.
Z equals negative 3.
Yes. Should be 2, negative 2, and negative 3? Or negative 2, positive 2, negative 3. Yeah, negative 2, positive 2, negative 3. Do you see any way that I could clean this up right now in blue? Any rows I can reduce?
5 by 5.
Now, it would be kind of difficult and involve fractions. It would be difficult and involve fractions if I tried to use an 11 to get rid of a 5. Even if I reduce this row to 1, 2, and negative 4, it still doesn't make sense to try to use an 11 to get rid of a 1. So what can I do?
2 steps. Divide by 11.
Remember, I can swap rows at any time.
So just switch.
Just make it easier by swapping the rows so that everything lines up the way you would like it to. Say this is equation 1. Negative x plus 2y minus 4z is 18. Why don't I just say 1/5 of equation 3 goes here? Y plus 2z is negative 4. Take this and move it down here. 11y minus 4z is 16. You see how it makes that last step smoother? This is one way to do it, yes.
I don't get in the second line, how do you get 60?
Because I took equation 2 plus 3 times equation 1's. Oh, I did, 3 times equation 1. 3 times equation 1 is 36. 36, oh, that's a negative 4. 54. 54, 34. Where did 16 come from?
Half of 34?
No, it's not. Honestly, I'm trying to do too many things at once. Can I? There we go. Okay. So equation 2 plus 3 of those, 54, and negative 20 is 34. Better? No. It's a single thing. Also, she interrupted me. Also, y'all are flapping your lips and numbers, and it's like trying to do in your head calculus while also watching Price is Right. Okay. Once I'm there, can y'all knock this out? I'm not going to touch equation 1. I'm not going to touch equation 2. But I am going to say equation 3 minus 11 equation 2's. Times the negative 11 and add it. Gone. Times the negative 11 is negative 22. And add it. It's negative 26z. Times the negative 11 is 44. And add it is 78. And it looks big and gross until you divide it and get z is negative 3. Then plug in a negative 3, get negative 6, add it. Y is 2. Take both of those and plug them in. We'll get 4 and 12 is 16, subtract is 2, negative, x is negative 2. Write your coordinate, negative 2, 2, negative 3. Okay. But if you're capable of the mental math, you're not being interrupted, then what these will come down to is it'll come down to like 2 to 4 steps, all contained in these nice little packets. Now you probably see where this is going. Much like with synthetic division, we got rid of all the variable soup because everything was nice and lined up by place value or by exponent value. So why bother if I can just write all the numbers? Same thing's going to go here, where a matrix is used to organize information. It's effectively a table. This is equation 1, equation 2, equation 3 with x, y, z, and my constant. Since I am organizing my system that way, I might as well just get rid of all the alphabet soup, because if I keep all of my x's in one column and my y's in one column and my z's in one column, if I'm allowed to move and swap any rows at any one time, that keeps all the stuff for that equation together. I don't need to put all the alphabet soup up there. I can just make a matrix out of it. So, to turn something into a matrix, typically we go alphabetical order, right? It was always X, Y, Z. So now that I got a W up there, W, X, Y, Z. W, X, there is no Y, Z. What do I do? 0 is a placeholder. 1, 4, 0, 1, 2. W, X, Y, Z. 0, 1, 2, -3, 0. W, X, Y, Z. I need a placeholder again. 1, 0, -3, -8, -1. W, X, Y, Z. Again, I need a placeholder. 3, 2, 3, 0, 9. Okay, it's just the coefficients and then the constants at the end that matter. And yes, this is headed to 4 variable systems. And 5. And 6. And we don't quite have enough time for it, but the back half of 6.3 is going to include up to 7 and 9 variable systems.
Screw it, why not be 15?
I mean, once you get past 4, once you start heading up to like 6 and 7, it's got some oomph to it. So, turn those into matrices.
Yeah, that I can handle. Just gotta make sure you keep your zeros.
4, -5, 0, 7.
What's that? -3, 7, 1, 0, 21, 4, 0, -12, 8, 5, 16, 0, -14, 1, 2, 1, 1, 2, 0, 7. Okay. I wrote that last one intentionally. I just kind of let it be sloppy. You see how if your handwriting's not the greatest and you're not taking the time to adequately space these, is that negative 14 and 1, or is that negative 1 and 41? Is that negative 141 and there was supposed to be a 0 there? Or did I just miss the next number entirely? Okay, you got to slow down your writing. This is where graph paper is really, really handy, because when you do these on graph paper, it's literally just a number per box. I recommend 4x4 grid instead of 5x5 for those who have issues with their handwriting size. Okay, 4x4 grid means there's 4 squares by 4 squares in an inch instead of 5x5. So it's just a different size. I strongly recommend that. You can also, I know I've seen them at Walmart, you can pick up 3x3 graph paper. If you write big, this works. So look at what they did. The purpose of this is we introduce you to row echelon form. We introduce you to Gaussian elimination and say, look, you don't have to scatter your work all over the paper. If you have a system of organization to it, instead of saying, I'm going to do 1/5 of that equation, and then I'm going to take equation 1 and equation 2, -3 equation 1 and equation 3. I'm going to use that. Doesn't this kind of start to just blur together? Just alphabet soup. But as soon as I start throwing things in boxes, it kind of compacts them, puts them in areas. And then I tell you, look, you didn't even have to do this many steps, because couldn't I have done this, which they said, but I could also do this in the same line. Couldn't I have said -3 row 1 plus row 3 here and had 0, 1, I swear that's a 1, 10, 9 there, completely skip this and go down to the next. The point behind this is, as I start to solve in a matrix instead, I can have my original matrix and I can work my way around the loop. We're getting to Gauss-Jordan, where I'm going to knock out these two first. Then I'm going to knock out these two. And then I'm going to knock out these two. And at the end of it, I'm going to be in something special called reduced row echelon form. Bam, there's your answer. Now, to do it in only 3 steps every time requires some mental math mojo, maybe some double shotting, maybe even some fractions. So you might have to do a little side quest and do 4, 5, 6 steps. I get some kids who are just a Yorkie chasing their tail. They take the whole paper and they get there in about 13 steps, but they got there. Instead of saying equations, now I'm just going to say rows. I'm still going to write out my order of operations with it. The goal is to be at a minimum in row echelon form. Row echelon form has some rules. The first non-zero term cannot have any leading, so first meaning leading, the leading non-zero term of any row can't have any leading non-zero terms, or sorry, any leading 0 terms above it. Meaning, it's literally still in row echelon form. It's still ranked like this, where I can't have right above this a 1 and a 0, because then they share the same rank. They're the same echelon. Okay? If I ever have a row of all zeros, it belongs at the bottom. Think of it like, all right, I'm I'm hanging out up in, you know, Mythic 2 and you're down in Silver 1 and this guy's like just starting. He's not even in Bronze. Like, you just started. Congratulations, you unlocked your first giant. Okay? Like, row of all zeros belongs at the bottom. So if something is in row echelon form or not, well, it depends. Do I have the correct echelon, the correct ranking, where the first non-zero term doesn't have any leading zeros above it or any leading ones above it? This one looks good. This is in row echelon form. Because if I needed to extend it, isn't there the row of all zeros below it? Okay. Look at the next two. First rank, second rank, fourth rank, all zeros. Yes or no?
Yes.
Yes. It just says the first non-zero leading term. Could you have a general and a major and nope, we have no captains. We go straight to lieutenants. Screw captains. Well, yeah, they're still in their ranks, so you're good. We're good. We're good. Ruh-roh, Raggy, because now you have, we all know how it works when you got co-captains, okay? When two people are trying to be the big dog. This one is not in row echelon form. Now, I also don't care about any zeros after it. The fact that there's a zero over here does not matter. I'm looking at the leading terms and the leading zeros. So, those three, are they in row echelon form? And if they're not, I want you to circle or highlight or something, who's the culprit? Who's ruining it? Okay? That one kid who doesn't let the whole class go to recess. Not just yes or no, but yes or no and who's the bad guy. Contestant 1, yay or nay?
Yay.
Because I got that row of zeros in the middle and it does not belong in the middle. Middle row. Words are hard. Someone's going to say, well, I could just swap that row and the one below it. Yeah, you could. Is it right now? Okay, that's some serious, but I'll change him after he marries kind of BS. No.
That's gonna end badly.
Okay? No. If it's bad now, it's always going to be bad. It doesn't work. What about these two? Okay. Rank, rank, rank. And I said I don't actually care about those zeros after it. This is not just in row echelon form. This is in reduced row echelon form. Ref. We call it reduced row echelon form because not only have I eliminated this triangle of values, I also eliminated this triangle of values. And you nailed it. Equation 1, 2, and 3, but this is x, y, and z. Look at what it's saying. X is 19. 1y is 4. 1z is negative 20. Reduced row echelon form is the answer. So this is perfect. And that's how Gauss-Jordan elimination says, I'm not just going to eliminate in a matrix to get to z as stuff and work my way back. I'm going to just solve the whole honking thing. This guy. Looks good. Looks good. Looks good. What the? That's when you go and do that interview fresh out of college and you get the job that someone with 10 years more experience than you didn't get because daddy owns the bank. Because mom already works there. Okay, because my uncle went to the same fraternity as the manager. This is when someone jumped ahead in line and is out of rank, out of order, not in row echelon form. All right, so you combine those two concepts. I can solve systems by doing these row operations to get in row echelon form. I can write a system as a matrix instead of with all that alphabet soup. Put them together, I get, let's make a matrix and solve it. Now I said a matrix is just an organization of data, rows by columns. I am so glad that we're not going to have this book anymore because these examples are so horribly unrealistic. This says that you're going to go to Italy during spring break and your average daily hotel expense in Venice is $60. We're talking like red light district here. Like there's tiles falling off the walls. Everyone on that floor uses the same bathroom and you can only flush it during the hours of midnight to 4 a.m. Like that, no. Okay, so I understand this is horribly unrealistic. Let's just roll with it. When they give you a table like this, they're giving you a matrix. Do you see the matrix? Okay. I can't really use those examples anymore because the movie came out 25 years ago and no one knows what the crap I'm talking about. But this is still my equations are the different things I'm talking about. My variables are now the different cities that I go to. So let's start by write your matrix. And as you're writing your matrix, could you clean it up? Could you reduce it to start your very first matrix? So I'll say this is really 1/60th row 1 divided by 60, divided by 60, divided by 60, divided by 60. What can I do to row 2? Okay. 1/10 row 2. Call it 4, 9, 3, 49. What can I do to row 3? 1/5 row 3. 3, 2, 4, 13, 26. That was the one they got on me last hour. Okay. So I start here. My goal is still to knock out this triangle. Should I move any of those rows? Should I swap any of the rows? I'm good to go right now. I've got a 1 up in the command zone, up in that top left corner. It's easy to use that 1 to knock out the 4 and 3 below it. So that's exactly what I'm going to do. Step 0 was to write my matrix, and I can work with it as I'm doing that. Now, step 1, I'm going to leave row 1, so I'm not writing anything. But I will say row 2 minus 4 row 1s. So I'm not touching row 1. Do you got the mental math mojo? Times the -4 and add it. 0. times a negative 4 and add it. 1. Times a negative 4 and add it. Negative 1. Times a negative 4 and add it. 1. Cool. How will I take care of that 3 in the bottom left corner? Row 3 minus 3 row 1s. Times a negative 3 and add it. 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 You see how you're almost there already. All I did was write down the problem, and then I've done 5 things. I've done 5 steps, but it looks like I've just wrote down the problem and did one thing. This is what a matrix does for me. It takes this big, long, ugly bleh all over my paper, and it condenses it down. It makes it efficient. It labels it so anyone can follow it. All right, how am I going to finish this off into row echelon form? Well, I'm just going to write that first one again. I'm not touching that. I'm just going to write the second one. I'm not touching that. But what do I do downstairs?
3 minus 2
Row 3.
Yeah. Row 3 plus
4 row 2s. 0 times 4 plus 0 is still 0. That's why I'm using that. Could I have taken row 1 times 2 and added it? Yeah, that would have gotten rid of it, but it would have put something right back where I just eliminated. I don't want to use row 1. I want to use row 2. Times 4 and add it. Bye-bye. Times 4 and add it. Times 4 and add it. Ka-clomp, 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 ka-clomp. And then there's a little kind of editing trick that we can do with this. Doesn't this say negative 3z equals negative 6? Could I do this? I'm still doing the order of operations, right? This plus 4 of that, and then divide it by negative 3, well, then I'll just cross this out and say 1. I'll cross this out and say 2.
Would you have to do it like that, or could you just say at the bottom z equals 2?
You can just say z equals 2. I'm showing you this as a preview for our Gauss-Jordan elimination. Okay. Now, you are correct. Negative 3z equals negative 6. Next to this, I now know z equals 2. This row says y minus z is 1. And I just said that's 2. So y equals 3. This row says x plus 2 of those plus 1 of those is 12. Well, that's 6 plus 2 is 8. Subtract. X is 4. Write your final answer, 432.
We don't write the 3-dimensional coordinate. Would it be counted as a point off?
Just do it. Like I won't.
Yes, but it's not a no.
I would probably take it, but it's irritating because that's the first thing I look at on a test. Do they got the right answer? Okay. If they got the right answer, now I'm going and looking at the work and making sure that your work matches it. Because yes, I can solve this without looking at my calculator, just by poking buttons and hitting enter in about 5 seconds. You still have to know how to do it. And if you don't have the work to back it up, I'll tell you the same thing I've told every pre-calc class. If you have the correct answer and your work does not match that correct answer, you are doing the exact definition of academic dishonesty. You are displaying someone or thing else's work in place of your own. I would rather that you did it for real, screwed it up. You know what, Forrest? I'm still buying you dinner. I'm still getting you a cheeseburger because you ran it all the way to the end zone. You went to the wrong end zone, but I'm still proud of you. I would rather that you did the entire thing wrong, missed 12 times 2 way back up here. Your answer's not even close. You got the nastiest fractions ever. You know you're wrong. But I can find exactly where your error is because I can follow your directions. And I can double check your arithmetic. And I see your error and I see everything after it. And now instead of getting all 8 or 9 points off, you only got 1 off. Okay? Now, the next one, I would just say, go ahead, try it, do it. I want you to start by writing out your matrix, rearranged and reduced and whatever you can do, just write the matrix to start with. Okay? And yet again, horrible examples. There is no way that this is financially feasible unless you are staying with some really shady people. Yeah, this is your supposed cost per day. Like transportation, $10 in Paris per day. Can you even get on the bus for that?
Maybe.
A daily bus pass?
You can take the subway. And I think you can have the pass.
Yeah, but you got to buy the pass though. That's what I'm saying. Can you even get a daily pass for $10?
Is he a
No, but like
decimal?
on a week, maybe like something like
I don't think the answer.
50.
No,
Doesn't
because
have like-
it's 10, 10, 10, and then 70.
So,
Yeah.
just saying. I know that these are not realistic.
Oh, wait, it's
We're
10,
still going to run with it.
City.
Okay?
So it's like this one can be like 5 or 1 and 1.
So that, yeah, that 80 is the amount of daily hotel cost in Paris. You would have a very, very nice box. You'd have a very, very nice box in a very not good part of town.
Even in town.
How are we supposed to solve it?
For $80, you can have a sleeping bag in the sewers beneath the Louvre.
Beneath the Louvre?
The Louvre.
Oh.
You know,
Place at the Louvre.
the place where they keep the fancy stuff.
Ah.
The fancy stuff is always stolen.
Yes, that is very true. It's fancy because they pillaged it from every country for 5,000 miles. You don't have to look sheepish. Look at the room full of colonizers in stolen land. Like,
Stop, please. What? Someone sent me a message, so.
okay. So what I'm going to do for this is I'm going to swap rows 1 and 3. I'm going to say row 3 instead of 1, 1, 1, 7. because I'm also going to say 1/10 of row 3. I'm just doing that to even write my matrix down. Because if I can get some work in before I start, you ever rearrange your room?
Yes.
Okay. Who's the kid that rearranges their room like 4 times every year? Where are you?
That's a lot.
Might be one of us. I'm going to say row 2, what's that, by 10 again? 1/10 row 2 is 5, 4, 5, 33. And then I'm going to say 1/10 again. 1/10 row 1, 8, 7, 8, and 50. Okay. So I'm just going to start with that. If you did that, yay. But now after that, you see how the reason we swapped it, I want that 1 up in that command zone, that top left corner. It makes life easier. If I've got that 1 there, I can knock out the ones below it. I can say row 2 minus 5 row 1s. I can say row 3 minus 8 row 1s. And I got 1, 1, 1, 7. Bye-bye times the -5 and add it. Times the -5 and add it. Bye-bye times the -5 and add it. -2. Times the -8 and add it. Bye-bye times the -8 and add it. What? Times the -8 and add it. Times the -8 and add it. What did those last 2 rows say? What does this say? Y'all ever seen Liar Liar? The pen is royal blue.
I think I've seen that scene somewhere.
Is the pen blue and the pen is red?
No.
No. Don't come at me with the kid who's got different color blind issues. Don't do it. Okay.
He only spent 7 days across all 3 seasons.
You just said y equals 2 different values. Is it possible that you spent both 2 days and 6 days in this town? Not including. You spent exactly 2 days in this town. Okay? And you spent exactly 6 days in this town. Like together? No. Wait, like separate? No. Wait. What? There is no solution to this. Because you have said, because now look at what's going to happen if I say row 3 minus row 2. Look at what happens when you do row 3 minus row 2. 0, 0, 0 equals -4. Does 0 equal -4?
Yes.
Okay. Which is why I wanted to do that one together, because it is unfair to have that be the first example of Gauss and Gauss-Jordan elimination with a matrix that you do on your own. It doesn't work. Okay. You will have an assignment. It's not long. And please, oh please, give me your notebooks and binders back. I'm going through those during block 3. Pick them up before you go home. If you need them for block 3, tell me. To the right. To the right, to the right.
Everything you own in a box.
Who is this? Chad, you goober.